the introduction to energy, the first notes in Unit 2. You can find them on page 2 of your Unit 2 packet. We need to know some vocabulary for these notes and the rest of this unit. And the first one is very important. It's the ability to change or move something, which is known as energy. So you can write energy on that first blank line on page 2 and follow along anytime something's highlighted in yellow like this. Then that can be written onto your notes. Pause the video if you need to in order to do this. The second vocabulary word we need to know is a portion of space and the objects in that space that are being investigated, which is known as a system. We need to determine what things that we're focusing on when we are considering energy, because if we focus on too many things at the same time, it becomes very overwhelming to try to think about how energy relates. As we were looking at these two images, we can easily determine that the one on the right has more energy, and that's because the car on the right is moving, whereas the car on the left isn't moving at all. It is stationary, and things that are moving have energy. Between these two images, the dog is moving, which means that the dog has energy, but this question asks which trampoline has more energy. And so if we're just looking at the trampolines in each image, the trampoline on the left holds more image, especially when the dog stretches it out, because when the dog jumps down on the trampoline is stretched, and then the trampoline has the ability to then push and move the dog. And the definition of energy is the ability to move something, which this trampoline has the ability to move the dog when it's stretched out, whereas this trampoline is unstretched, so it's not storing any energy. And in these two images, the object with more energy is the explosive on the left, and that's because of the chemicals that this explosive is made out of, that when detonated would be able to move and change other things, whereas the chemicals that make up this rock are not as able to affect that change, and therefore it's not storing as much energy. So not only is something moving or being stretched out showing energy, but just some chemicals inherently have, they store more energy than other chemicals. When we are considering energy, we need to make sure that we choose a system, which means to choose objects that are relevant or choose objects that are important to each situation. So in the situation on the left, we have a person jumping off a building with a bungee cord. And so we would want to consider the person because their height is changing, and we'd want to consider the bungee cord because it's stretching out. On the right, we have a person on the skateboard, and so we would want to consider both the person and the skateboard because both of them are moving. We can't just look at the person or just look at the skateboard because both of them are showing energy. And so we want to make sure that our system is not too small, but also not too big. Like in the first example, we wouldn't want to consider the building because the building isn't changing energy at all. And so it wouldn't be a good item or a good object to be in our system when we are considering that problem. So under your definition of system, there's a blank space without a line that you can write down the first law of thermodynamics. We're going to talk about this first law of thermodynamics throughout this year. And so it's very important that you write the title of it and then complete what that first law is. So the first law of thermodynamics states that the total energy of a system is constant, which means that energy cannot, or energy can be transformed from one form to another, but cannot be created or destroyed. That's going to be very important throughout this unit too, but also into the next unit and units after that, that allow us to be able to consider situations and make sure that our total energy that we start with in a situation is the total energy that we end with, and that even if it transforms, it cannot be created or destroyed. So now we're going to talk about different types of energy or different flavors. The first type is kinetic energy, and kinetic energy is energy of an object in motion. So two things that we should keep in mind when we're looking at objects in motion is that faster objects have more kinetic energy and more massive objects have more kinetic energy. So if two items are moving and one is faster than the other, then the faster one has more kinetic energy. Or if two items are moving at the same speed, but one is bigger, it has more mass than the other one, then the more massive object stored or has more kinetic energy as it's moving. Another flavor of energy is thermal energy. Thermal energy is the energy of particle motion. And when there's more particle motion, that means that there's more thermal energy. This is often very difficult to convert into other forms of energy. And so, for example, if you're watching the GIF on the bottom corner, as the player is running, they have kinetic energy. And then when they slide on the dirt, they move the particles of dirt, which increases the thermal energy of the dirt. But then the baseball player stops moving. And so the energy is kind of stored in the dirt now and very hard to get out of the dirt. Another name for this is dissipated energy, which kind of sounds like disappearing energy because it's hard to regain. And the last type of energy we'll talk about is potential energy, which is energy stored in an object because of its position or composition. And so potential energy can actually be split up into multiple different types. But I think the easiest one to see is when something has more height. So this object or this ball on the right side has more potential energy because it's higher up and has a hill to roll down, whereas the ball on the left has very little potential energy because even if we gave it a little push, it wouldn't be able to go up the hill, and so it's kind of stuck where it is. So for the 5 types of potential energy that we're going to discuss in this class, the first is gravitational, which has to do with how high up an object is. Things that are higher have more gravitational energy, and they have more potential to then move by falling or rolling down. The second type is spring energy or elastic energy, and that's the type of energy that's stored in an object that's either stretched or compressed and wants to return to its relaxed state. So a spring or a trampoline or a bungee cord, when you stretch them out, they have energy stored in them because they want to go back to their original size. The next type of potential energy is chemical energy. Chemical energy is the type that is stored in certain chemicals. And we find this in food, like that's how humans and other animals consume energy, is they eat food and use the chemicals in that food to operate, or in other fuel sources for things like cars. So gasoline, diesel, ethanol, alcohol, those are all chemicals that store energy that can then be released and turned into other types of energy. The fourth type is electrical. And electrical energy is energy that we associate with electric current and the movement of electrons through circuits. And then the last type is atomic. And atomic energy is the energy stored in atoms, which is able to be released when we fuse them together or split them apart.